Okay, we're going to look at something called reference triangles and reference angles. So, how to draw a reference triangle for some angle, let's call it theta, okay? For some angle theta. So what you do is, the first thing is draw the terminal side, okay? If possible, it will be the hypotenuse of the reference. Reference triangles are always right triangles, so it will be the hypotenuse of the reference right triangle. Okay, it will be the hypotenuse of the reference right triangle. Then, and this is the key, this is what everybody forgets, connect the hypotenuse to the x-axis at 90 degrees, okay? And that'll be it. So we'll sort of run through this, make sure you connect to the x-axis at 90 degrees. We'll do some examples here, okay? Draw the reference triangle. And we'll go even further. Let's label the angles and side lengths appropriately, okay? So here we go. So draw the reference triangle, label angles and side lengths appropriately. So example 1, the reference angle the angle we're going to look at might be, let's say 120 degrees. So we go to our plane, we rotate 120 degrees from 0, so that's past 90, that puts us here. So our terminal side is going to look like this, let's say. So this is 120 degrees. So this is our hypotenuse. Now we need to connect to the x-axis at 90 degrees. This is where you've got to remember, you're either going to connect this way to get a 90 or this way to get a 90. We don't want to connect to the y-axis. So our reference triangle is going to be hypotenuse to the x-axis at 90 degrees, and now we've got our triangle, okay? Now we want to label the sides and angles appropriately. There are 3 angles, 3 sides of that right triangle, okay? So if this is 120 degrees, then this angle here has to be the other 60, because the top half of the plane makes up 180 degrees. And this is 90, this is 60, so this up here has to be our 30. Now this is a 30, 60, 90 triangle. So let's work with a hypotenuse of 1 to make things simple. So let's say the hypotenuse has a length of 1. If that's the case, then the short leg, the leg opposite the 30, is a half, and the long leg is the square root of 3 over 2. Now the 1/2 is going to the left, so we'll say it's negative 1/2, and the square root of 3 over 2 is going up, so we'll call it positive square root of 3 over 2. So that's the reference triangle for 120 degrees. Let's go ahead and define a reference angle. So first of all, so the reference angle is the angle, let's be very specific, is the positive, has to be a positive angle should say non-negative would be a better answer here, but it's between 0 degrees and 90 degrees if you're working in degrees, or 0 and pi over 2 if you're working in radians. So it's the positive angle between 0 and 90 degrees. In fact, we don't even have to say positive if we describe it that way, right? Is an angle between 0 and 90, or 0 and pi over 2, that measures from the terminal side to the x-axis. Okay? So in this case, our terminal side, or our hypotenuse, is here, so our reference angle is 60 degrees. So one way that we do this is, if we call this theta, then the reference angle, we will put our theta, the same thing, with a bar over the top. It's called theta bar. Let's write that out. Theta bar. The reference angle in this case is 60 degrees. So theta bar equals 60 degrees if theta equals 120 degrees. Okay? So here we go. We're going to add to our instructions now. Draw the reference triangle, label angles and side lengths appropriately. Identify the reference angle. Alright, so let's do a couple more examples. So let's say our next angle, let's say, is 5 pi over 4. So 5 pi over 4, we could think of this, we could count pi over 4s. We could also think of this as 1 1/4 pi. That's how many pi's we have, because 4 goes into 5 one time with 1 left over. So if we're looking at this, drawing a picture, here's 0. Here's 1 pi, and we need to go 1/4 pi more. Well, a 4th pi looks like that. So this is our hypotenuse of our reference triangle, connected to the x-axis at 90 degrees. So our reference triangle is here. Pi over 4s are 45 degree angles. So this is 45 degrees, this is 45 degrees. Notice that we always get this angle before we get this angle, right? In the previous example, we got our 60 degree before we determined our 30 degree. That's because it's rotation around the origin. So the same thing is true here. So if theta, if we call 5 pi over 4 theta, then theta bar is 45 degrees, or pi over 4. Okay? Either one of those would be fine. That's our reference angle measured to the x-axis from our terminal side. Now the side lengths, if we assume a hypotenuse of 1, then the sides of a 45, 45, 90 would both be the square root of 2 over 2. The horizontal goes to the left, so it's negative, and the vertical goes down, so it's also negative. Okay? Let's do a couple more. Let's see if we can draw the reference triangle for, how about 28 pi over 3, which is the same as 9 1/3 pi. So 9 pi is odd, so 9 pi is over here. Then I need to go another 1/3 pi, so I cut into thirds, which are these cuts, so 9 1/3 pi is here. So that's my terminal side. Drop to the x-axis at 90. And each of these is pi over 3. So our reference angle here is pi over 3, or 60 degrees. Okay, so there's our reference angle. So this has to be 30 degrees, hypotenuse of 1, short side 1/2, long side square root of 3 over 2, both negative because we're going left and down. Okay. Now let's take our focus off of the triangle for a moment and let's do some problems with just reference angles. So example, determine the reference angle for, and we'll use a different letter now for an angle. Let's say the angle is beta, and let's say that angle is, how about 12 pi over 7, okay? So, reference angle for 12 pi over 7. So here we go. We have to understand pi over 7s. So pi is here. So we have to cut, let's ignore the y-axis, we have to cut this into 7 equal pieces, okay? So if I'm straight up, this is 3.5. This is half of the 7 equal pieces. So I've got, this will be 3 pi over 7s and 4 pi over 7s. Okay, so I need 2 more. So 1 pi over 7, 2 pi over 7, 3 pi over 7s here. This will be 4 pi over 7, 5, 6, 7 pi over 7. So I've got 7 equal cuts, okay? But I need 12 pi over 7s, which is the same thing as 1 and 5/7 pi. So here's 1 pi, or 7 pi over 7, and I need to go 5 more. Okay, so there's 1, 2, 3, 4. Sorry, that 3 is not very good there. 3. The 4 is not very good either. Sorry about that. 4, 5, 6, and 7. So I need to rotate. I need to go to 1 and 5 more of those. So 1, 2, 3, 4, 5. This would be my terminal side. Now these are not 30, 60, or 45 angles, so I can't draw one of my reference triangles that I'm used to, but all I want here is the reference angle. So in other words, what's the angle from the terminal side to the x-axis? This is beta bar, right? I would always choose the shortest path to the x-axis, not the longer path that we have over here. Now what is beta bar? Well, you can literally see, because we've cut this into pi over 7s, this is 1 pi over 7, this is 2 pi over 7. So beta bar is 2 pi over 7 if beta is 12 pi over 7. Okay, so that's a reference angle when you're dealing with an angle that's not as common.